Right. So I think 18 hours on the dot, but we only have 4 people in the house, which is fine. I'm just going to start by asking if people have any specific questions with regards to what we were looking at the last time we met. And I'm especially interested in finding out if you've gotten to the stage where you've started with your respective document analysis and, more importantly, the system interface analysis process. Right? So for you to be able to implement the features that will require you to interact with those external APIs, you're going to have to do that. There's no way about it, right? So I don't know if people have gotten to that stage yet. Any thoughts? Any questions? Maybe we'll start with questions and thoughts. Okay. Well, if there are no thoughts or questions, then I suppose we will start. I wanted to say something. I don't know what that was. But anyway, I've forgotten what I wanted to say. All right. I've forgotten what I wanted to say. I wanted to say something. Jesus, I should probably start using sticky notes. Okay, so we continue our conversation. If there are no questions, we got to a stage where we're still with requirement specification, right? So we started off with the elicitation, our requirement specification. And at some point this week, by the way, there's going to be a group assignment where you get to identify or tabulate the different elicitation techniques that your group is going to leverage. Marks are obviously going to be distributed towards proof that you actually collected the, that you actually gathered the requirements by making use of well-established elicitation techniques. So there's nothing like going around in circles here. Wow, okay. So we stopped off at the stage where we were looking at drawbacks of so-called natural language specification. We're about to transition into our discussion of various notations. I don't know if we discussed notations. I'm going to pause here to ask my memory here. Did we discuss these different requirements specification notations, or this is where we left off, yes?
That's where we left off.
Yeah, okay, someone finally spoke. Okay, right, I should start using sticky notes or something. All right, so we're just going to gloss over some of these requirements. Specification.
You haven't shared your screen.
Oh, thank you for reminding me again. There we go. This is one of the reasons why I should be using sticky notes here to remind myself to share the screen. Checklist of what to do, right? Thanks, Miss Mary. Right, so we're just going to quickly gloss over some specification notations. And the reason we're going through some of these notations is because our final SRS document, right? So our final SRS document, similar to what you're seeing here, is going to incorporate some of these notations. So you will see that once I share this document, you will notice that there are some graphical notations that we're going to be expected to include into our respective SRS document. So it's not like your SRS document is only supposed to include is it a tabular notation, for instance. You can have a mix of a tabular notation combined with nice fancy sticky figures, so-called use case diagrams, right? And the idea is to make it easier reading. We gave an example and we did a comparison between a representation that makes use of natural language a natural language representation where you just have a text that's structured into sections and a table, right? And we discovered that a table is, or at least I hope you notice that a table or a tabular notation is a lot more intuitive. It's much easier to synthesize. Better yet, when you incorporate use case notation, it's even much easier to make sense out of that. At least developers will find that a lot easier to synthesize, right? The open-ended natural language notation will probably be would be useful to your clients or your customers. Why? Because your customers will not understand what it is. Right?
Hello, sir. There's a break in sound. I don't know if you can hear us.
Bank or something. The people level 0. It might just be Peter here. Right? Hello, is there a break?
Hello?
Okay, it's back to normal. Yeah, there was a cut, but it's back to normal because it was bumping, like it was skipping. But it's back to normal.
All right, thank you. I was going to swap my connection. All right, so we're just going to start by just passing through these requirement specifications. And again, these will come up once we start looking at, we'll have a walkthrough of the software requirements document, software requirement specification document example. All right, so it turns out that there are different notations that are available out there, right? So we'll go through these in sequence, but the obvious one is a natural language where you represent your requirements in sentence form, right? And each sentence will typically express one requirement. And then you have the structured approach where the requirements are written in natural language, obviously, but you make use of a standard template. Remember, when we were looking at guidelines of how to write a good software requirement specification document, one of the things we highlighted was that you should either adopt a standard yourself, if you're a development firm, or use an already existing standard. I gave out.
Hello? Sorry to interrupt, Stu, we are not getting you. I think the network is tripping.
Okay, let me just swap then. Sorry about that. Give me a minute or so and just swap my connection. Ooh. So how is this connection?
We can get you now.
Okay. Let me know if this fails as well. It's my connection. This connection has been contented right now, so I'm no longer using my tab allocation. It might just be the case that this will start misbehaving as well. So just let me know if this connection starts acting up, and then I will swap it out with something else. There's always a plan. I will swap it out with a plan. We can even go up to plan Z, I suppose. I don't know. Maybe not. All right. So we're just, like I was saying, we're just going to gloss over these different notations here. We were talking about this idea behind the structured natural language notation, where you use a template, a standard template, the pre-existing template. And we gave away something last week, or is it before last week? We mentioned that in ICT 3022, we are going to adopt an IEEE standard, granted a modified version of an IEEE standard, right? So this is a sort of template that we're going to make use of, right? All you do is you're plugging in these values, and one of the sections actually walks us through this particular document so that we understand exactly what sort of content we put in this document, right? So this would be an example, a classic example of the structured language notation. You're using a pre-existing template. And templates are good, right? Templates are good because there's a bit of consistency. Why do you need consistency? You need consistency because it won't matter who exactly you give this document to. If they're an expert, if they've written software based on some pre-existing SRS document, they'll be able to make sense out of the document. They already know the sort of sections they expect to find in this SRS document. Right, so consistency is key. So structured notation, revise these things just now. There's also a design description language where you use a programming language, right, with more abstract features to represent the requirements. You can also go with the graphical notation, where you use certain artifacts. Again, these are based on standards. And again, as our SRS document evolves, by the way, you'll see that these graphics will appear, right? Certain specific graphical notations will appear. Like for instance, we will soon learn how to create a data flow diagram like this, a context diagram, which is a data flow level 0 diagram, right? We will learn how to come up with these sort of notations. These are all graphical notations. Right? There are a lot of such notations, right? And believe it or not, everything you see here has a meaning, right? I know it sounds funny. It looks like a toddler drew this, but this is actual notation that we're going to use, right? During our discussion of so-called UML diagrams is the ones we're going to look at. So we're going to look at some of these graphical notations. And for certain sophisticated applications, you might want to use mathematical representations to represent the requirements. Right? Just to rub in some of these notations here. Oh, and by the way, in our SRS document, we will have the following notations. There'll be a mixture of natural language notation. There'll be structured notation because you're using a template. We shall also have graphical notation, so a combination of these three. So as I mentioned, this whole structured requirement specification notation involves you writing the requirements in a standardized way, right? So usually, if you're using a template, for instance, there will be predefined sections where it is expected that you have certain types of content, and content has to be phrased or written in a certain way. In fact, the template that's going to be shared with you has placeholder text, which will tell you, right, this template here, it will tell you what exactly you should include in the template. So for instance, say project name goes there, right? So that you replace the project name with the name of the project. If you go to the actual body of the document, you have placeholder text here that tells you exactly what sort of content is expected here, right? You know, these different sections of the document. And better yet, there are specifics on subsections and subsections that you're supposed to have in the various sections of the document. In certain instances, you have the freedom to decide what to put there, like I think under non-functional requirements, there are predefined EDTs and non-EDTs. These are non-functional requirements, but you are allowed to add additional requirements, right? A key thing here is there's a template, a pre-existing template. It's a structured notation. So there's also a form-based specification here, where you get to define, you get to predefine the specific functions or entities associated with whatever system you're developing. You provide detailed descriptions of what sort of inputs are expected by your system and what output you get back. Information about information needed for computation, right? You will see this in the and I know it's a combination of tabular, but also in the tabular notation, when we're describing use cases, what you'll notice is that we tend to define what we call as preconditions and postconditions. So the status or the state of the system before you provide it with input and its status after you provide it with input, the various actors that are associated with that input. So in case people are a bit lost here, I'm just going to quickly refer to, I should have downloaded this, but I like referring to this, this project. I think it was well done. It was a software engineering project and it was well done. Let me just see if we can find that project. This was in 2015 or something. And I hope I wasn't just dreaming about this. I hope this particular project does have, I don't know which component this was, but I hope it does have metadata map or gestion manager. So if you look at these use case descriptions here, you notice that I hope this guy has preconditions and postconditions, right? Yep. So preconditions and alternative flow, postcondition, precondition. And so the status of the system before and after. You're specifying what sort of input is being given to the system through a description of the flow. So the user selects a collection, then the user enters the collection. There's a back and forth here describing the interaction that takes place really. So input, output. So form-based. So descriptions of the action that need to be taken by the users of the system, right? Preconditions and postconditions, exactly what I was talking about here. And the sort of side effects. So what is the behavior of the system here? It turns out that there are certain instances where you provide the system with an input and something unexpected will happen, right? You would have to describe or explain or outline exactly what that side effect is going to be. What happens if I log into the system, I provide username, password, the system logs the user in? Well, what if I provide the wrong password? What if I provide an inexisting, a username that doesn't exist, right? You should be able to explain all these different side effects, right? So form-based specification. And then there's a tabular specification where you're really just trying to supplement, you're supplementing the natural language notation. And in fact, the example that we just looked at here, the use case description that we had in the table, is a classic example of the tabular specification, right? It's kind of funny here because it's a combination of the tabular specification and the form-based specification at the same time. So if you look at this, yeah, the interaction, everything is being represented in a table, right? It turns out that these things, postconditions and preconditions, can be represented in an alternative format. If you go to your template, the template we're going to be using, what you will realize is that if I go to the features of the system here, if I go to the features of the system, I hope I'll be able to find the features here. Is it the functional requirements, I guess? I don't know. Oh, this is a horrible example. It's not there. Okay. No. If we go to the original IEEE specification here, right? This is what we're using here, right? The standard here. What you will notice is if we go to, I hope this is there. If we go to the appendices section, which has a variation of how you can represent the functionality of the system, you will notice that the representation of the preconditions and the postconditions, I hope this is the case, representation of the preconditions and the post-conditions is, and it's not there. I wonder where that was. Where did I see that? But anyway, the point I was trying to put across here is that you can represent the preconditions and the post-conditions in, I think I know where this is coming from. You can represent the preconditions and the post-conditions in use case template. You can represent the preconditions and the post-conditions like so. You see this? So we are using natural language notation, not table here, right? Same information that, if you notice here, same information that is being presented in tabular form here is just being represented in, I guess it's a combination of structured notation and natural language notation, right? So you have your preconditions and dissection, right? You specify the preconditions, the post-conditions, the normal flow, alternative flow, any exceptions that might exist. And what you will soon see, right, as when you get the hang of what we're doing here, you will realize that.
Hello, Doc.
This, yes, sir. Am I breaking again?
Yes, we're breaking. Then we couldn't see the screen sharing.
Oh, is that the case for everybody?
Yeah, somehow.
Simon, what do you mean somehow? You just joined us. You liar, Simon. But you're from the Bible, right? Is it Simon Peter or something? But okay, let me just swap my connection again. I do apologize for the breaking transmission. Just give me a second. Let me just swap out my connection. I know this connection is bound to work here. Let me see if it's punishment from the gods or something. Listen, if portions of what I'm saying, can you hear me now?
Yes, sir.
Yeah, what's taking you so long? Okay. Yeah, so but I just swapped my connection. Is there anybody who can't? Am I breaking for anyone, or can you hear me clearly now? I don't know. So I was going to say here, if there's no comment, then I guess you can hear me. I was going to say here, you want to pay particular attention to some of these things we are talking about. If there's portions of what I'm talking about that doesn't make sense, please ask, right? It's important that you understand this. You are going to do this, right? You will have to do this. Next batch, next major assignment will require you coming up with this software specification document, version number 1, without the visuals, without any context-free diagrams, without any use case diagrams, without any interaction diagrams, right? Without any state machines, none of that. But version 1 is just going to be, I guess, a scaffold of the document. So you better let me know if there's something you're not understanding here. All right. Opened up a lot of things here. All right. So you typically use this to supplement the natural language. And by the way, most of these notes are from your prescribed book, right? And you will find some of these examples that I'm being made reference to in the prescribed book. So you use the tabular specification to supplement the natural language. And we explained last week, and I want this to sink in, that depending on who the reader of this SRS document is, they might prefer, or it might be a lot easier for them to understand the message you're putting across if you represent this information in a certain way. Your average developer, software developer, will prefer that the interaction between the user and the system is represented in a tabular form, something similar to this. Because it's a lot easier to synthesize this. This is much better than something that is represented as follows, right? Turns out that it takes a lot of time for you to understand what's going on here if you are to read through the description of the use case, right? When it's represented in a structured notation like this. So this example here, just skip this. This example there's a snapshot in the textbook, so you might want to look at it. I don't know if it's going to be useful, maybe not. So it just gives you an example of the tabular notation, specification, just a screen grab of an example of this sort of notation. It's here actually. So this is how maybe you represent it, right? Example is to do with an application that I guess it's an application in the health sector or something, an insulin pump system, right? So you have an action that's supposed to be taken alongside a condition. So if this condition is fulfilled, then this is typically what happens. So the dose here is equated to 0 if R2 is less than R1, for instance. And the takeaway point here is, I hope you appreciate this, the fact that it's a lot easier for you to understand what's going on by using this sort of notation rather than writing these things down using natural language. Right? That's the key takeaway point. So you'd have to make very smart choices depending on the application domain you're working in, depending on the complexity of the interaction between the user and the system that you're trying to model, right? It might just require that you use an interaction diagram, perhaps, maybe it's a tabular specification, or just plain old natural language specification. So another notation is so-called use cases, right? So they'll mimic some sort of scenario that happens, right? As a user is interacting with the system. Use cases are a part of UML, so-called Unified Modeling Language, which is going to be a topic of discussion in the next lecture series when we start looking at system design. And what a use case does really is it identifies the key actors associated with the system that you're implementing. So the entities that are going to be interacting with the system. So the actors would be the actual end users, but also systems, third-party systems that might require to interact with your system. So if you have a web service, for instance, which provides input to the system, that web service would be modeled as, or it's viewed as an actor. So you'd actually represent it as a sticky figure, just as you would an actual end user, a human being interacting with the system. The use cases themselves, these would be ellipses. They will represent or describe the possible interaction that happens with the system. Almost always the case that the graphical notation itself, the use case would be, the graphical notation, the graphical model would be supplemented by tabular description. It's rarely the case that you'd have a situation similar to this, where this person only, and I guess this was the final output, right? In this project, the only thing they were providing, and I hope maybe the other person did something different. This is the ingestion manager. It's just check the metadata mapper, I guess. It's usually the case that you supplement one with, and this guy did not do this, which is quite sad. Okay. This is quite sad. This person did not include any use cases. He took a different approach, right? He's taking advantage of rapid paper prototyping, I suppose, right? So no use cases. But the takeaway point is that you typically supplement this with a graphical notation, which we'll look at just now. And we discuss use cases actually in great depth during system design, because we focus on a broad spectrum of different artifacts that are part of UML, not all of them, but just some of them, the more relevant ones. Right. So you might also supplement or complement the actual use case descriptions and the use case diagrams with sequence diagrams, right? These will actually model the actual specific interactions that happen. So user is trying to log in or something, you model that sort of interaction that takes place between the user and the system. using bars and directed arrows, specifying what sort of specific methods or functions are associated with your system. Right? So it's not uncommon for you to incorporate, if you're trying to explain a system feature, you'd incorporate use case description, use case diagrams, and sequence diagrams. A sequence diagram is just a type of an interaction diagram in UML. So the use case diagram that, sorry about that, use case diagram is something similar to this, right, where you have a bounding box that represent the automation boundary or the system boundaries, and then the ellipses will represent the specific use cases, right? The sticky figures would be the actors. So actors are actual human beings that would be or actual roles that would be interacting with the system, but also external systems, right? And we have a lengthy chart about how exactly you get to represent use case diagram. This is a simplified view. There you can extend certain use cases, for instance. So there's the specific details that will be provided on how to make use of this notation. The key takeaway point here, again, right? If you're still wondering, why are we doing this? The key takeaway point is you want to make use of a notation that will be understood by the vast majority of people that could potentially develop this piece of software. The idea behind what you're doing, the idea behind this software requirement specification document is that you develop it. It doesn't matter if you ship it to somebody in India or China or the USA or on the Copper Belt. They should be able to understand what it is you've produced. They will be able to understand this. This is part of UML, right? It's a standard. They will be able to understand this, right? They look at a document like this, right? They'll be able to know what sort of template was used, right? They'll be able to understand this, this diagram here, DFD. Right, is this making sense? Any random thoughts or questions here? Just notation. All right, so next up is just this brief discussion of the so-called requirement specification document. I've been thinking, by the way, we are supposed to wrap, I hope we wrap up this by the next time we are meeting. What I want us to do is, I just remembered something I wanted to talk to you about when I said I should have used sticky notes here. What I'd like to suggest is, if you're a part of a group, if you're representing, I guess one of 5 people working on group X, for instance, I would like to suggest that you ensure that you attend the Friday class, or at least have one of your group members attend the Friday class. I would like for us to, because by then the elicitation assignment would have been made available, but also the assignment to do with the software requirement specification. So to ensure that we're doing the right thing, the correct thing, I would like for us to have we'll call this an informal discussion on Friday, where we get to discuss the elicitation techniques that your respective groups are working towards, so that we course correct before you do the wrong things, right? Because it turns out that if you do the wrong things now, if you did the wrong things at the proposal stage and you didn't effect the changes, what you're doing next is going to be messed up, right? So we want to avoid that. We want to get to a stage where when we start implementing, we are doing the correct thing. When we start testing, validation and testing, we're doing the correct thing. Because it turns out that when you're validating, when you're testing, input is, yes, you guessed it, input is the specification itself. And so we want to make sure we're doing the correct thing here. Okay, so we're just going to walk through software requirement specification document just to try and understand what this is all about. So it turns out that this is nothing more than just that official document is actually one of the formal outputs from the software specification process, right? It directly feeds into the system design. If you remember the waterfall model, requirements engineering, design, implementation, testing, evolution, right? And so it's an official document that is supposed to explicitly state what the system you're developing is going to do, or rather, what the developers, the people developing the system, are expected to do, what sort of functionality or features the developers should be implementing. And so it should include both the user requirements and the system requirements, and this makes sense because at the same time, besides it feeding into what the developers are expected to do, it serves as a contract between the entity that's developing the software and the customers, the clients, right? So it's this formal contract that you have. It's a reference point, if you will. So during validation, if some random customer comes up to you and tells you to say, no, but this is not what we agreed to, you fish out whatever version of the SRS document you are working towards to point towards a specific reference of the bone of contention, right? The problematic requirement. Verify that it's actually indeed what the client requested that you do, right? So it also serves as a formal client here. Just to mention here that it's not necessarily the design document per se, but it does include certain aspects of design. So you have certain design artifacts that will feed into that particular document. So for instance, the DFD diagram level 0, for instance, the context diagram is a design artifact, but you typically find it in an SRS document. Use case, I'm wondering if we should have architectural diagrams. I think we also have architectural diagrams in this. I think so. I hope so. Oh, there was also logical data models, right? This is a part of design, but it's integrated within the SRS document, obviously. Right, but the bottom line is it's not necessarily a design document, right? But it does have certain aspects of the design. But fundamentally, what it should do, what the document does, is it sets out or it explicitly states what the system is going to do. It's what, right? It's a requirement, not how it's going to be done, but it's the what, right? So functional requirements, non-functional requirements, this should be what we should be thinking about here when we're referring to what the system does, not how it's going to do this. And because it incorporates both the user requirements and the system requirements, you realize that there's a broad spectrum of users that get to benefit from this software requirement specification document, right? Down from the different users associated with the clients to the users associated with the project team that's developing this piece of software. Remember that if you are this company that develops software for a living and you get this contract from government to develop some sophisticated software, your project team will be composed of different people: programmers, quality assurance engineers, project managers, right? These are massive projects we're talking about, business analysts. And so what we're saying is that there's a subset of those users in the side of the company developing the software that will benefit from reading this software specification, software requirement specification document. But also on the part of the client itself, you have again a broad spectrum of users that will benefit from the document itself. So some random examples here is system customers, right? So these will be the people that will specify exactly what sort of changes should be made in the event that you misrepresented certain specifications. Managers, right? And I'm wondering where this manager thing is coming from here. So this will be the managers associated with the company, right, that's developing the software. Usually the bidding process is done by high-level entities. So there'll be potential users of the system. System engineers, right? So if you're developing a software for a large organization, it's almost always the case that that large organization will have an IT department, right? An IT department that has people that are knowledgeable when it comes to software development. And so those particular types of users will be able to understand the system requirements, for instance, right? So they're direct beneficiaries. And it makes sense because once you deploy that system, if something goes wrong, the first line of defense, right? Troubleshooting is typically done by those particular people. So you need to understand exactly what sort of interaction takes place as end users are interacting with the system. But also test engineers, right? So the people that are going to conduct validation and testing. This is on the side of the company that's developing the software here. So use the requirements as the basis to create test cases, for instance. Maintenance engineers, as you're undergoing that evolution process, you constantly make reference to the requirements that appear in the SRS document. Right. So you notice here, broad spectrum of users, and the types of users are dependent on, I guess, the size of the software that you're developing, the nature of the organization you're developing that piece of software for. Right. Some of these roles might not be applicable, but what I would encourage you to do is to think about potential readers of the SRS document that you're going to develop. Right. This is what you should be thinking about. Are you going to have test engineers or something? System engineers, I don't know, right? System customers or managers, do we have managers? I don't know. Is this making sense? I don't know if I'm still online here, but I'll assume I'm still online. All right. For ICT 3020, we are going to take a structured approach, and so the template that the standardized template that we're going to make use of is based on, it's loosely based on the IEEE standard 830-1990, right? It's a bastardized version, so it's slightly modified. If you look at this document, which I've shared on the Moodle, you'll notice that our template, it borrows from that particular standard, but there are a few alterations or modifications. It doesn't matter, because what we're saying is you just have to ensure that you adopt a pre-existing template or invent one of your own. Just ensure that you're consistent. And you soon see how this is possible, because it turns out that there are certain portions of the document where you get to explain exactly how the document is structured to help whoever is reading the document understand as they're reading through the document, right? What's important is you just have to ensure that you're consistent with what you're doing. And it turns out that there are a number of standards. So if you Google up SRS document templates, you notice that there will be a number of hits that will come up, but a huge chunk of them are based on recognized standards like IEEE standards, for instance, which is what we've adopted ourselves. So if you just Google up this standard, you should be able to find more information about this document. I do encourage you to read through this document. Very useful document. It will have, it's a short document, by the way, just 39 pages, right? You can quickly skim through this. Some of the, excuse me, some of the content here is irrelevant because some of it is just in the, it's an appendix section which shows you different variations of how you represent functional requirements, for instance, or features of the system, right? So it's not a long document per se. It's a short document. I do encourage you to go through this document. It outlines exactly how you're supposed to structure SRS document based on this particular standard. Yeah, so there's a very nice section where they'll explain to you what you need to take into account for you to produce the so-called quote-unquote good SRS document, right? And then, more importantly, I guess section 5 here would be a description of the different components of the SRS document. So the introduction, overall description, specific requirements, supporting information, right? And you notice that these parts of the SRS documents are outlined from page 11 up to 19 will be somewhat loosely aligned with our adopted template here. Introduction, overall description, features, data requirements, external interface requirements, non-functional requirements. And I know what you're thinking, well, item, but this doesn't match with that. Well, it does, right? It does, because all of these are requirements under section 3, such that they're represented differently here. All of these are requirements, including this last part here. This is where you find the EDTs, right? The non-functional requirements and other requirements. Good stuff. So again, the structure is as follows. So we're just going to really just try and see if we can gloss over some of these parts, and then we'll go through all of them, I guess. I don't know if it's important. And then we'll look at a partially completed sample SRS document, which is based on the problem statement associated with a smart IR deposit application. Right, so that's a structure right there. And in terms of the specific sections and subsections and sub-subsections associated with this document, you'll notice, by the way, that it goes up to level 3. It uses a level 3 hierarchy here. The template we've adopted uses a level 3 hierarchy, so we don't expect to find 1.5.1.2. This is a level 3 hierarchy, right? So it has I think it has 6, is it 6 or 7 major sections? There are some sections that are missing here, like logical design is not part of this. So the introduction will just provide you with an overview of what the system is about, and the idea is you want whoever is reading this SRIS to understand what that document is about. It also has a portion that outlines exactly how the document is structured, right? So when somebody reads through the introduction, they will know what to expect in the remainder of the document, right? How it's organized, how they should read this SRS document. The purpose subsection will just identify the product that you're building or the application that you're building. It's just a very brief description of the product that you're building. And then the section associated with the document convention is just a rough description or a brief description of what standards, as far as the writing is concerned, you are using. In certain instances, you find people omit this, but for what we are doing, I do encourage you to do this. You'll notice that the document convention that we have here is just brief description, telling whoever is going to read this document that these are the font face format that we're using. This is the writing style that we've decided to adopt, right? This is a specific font that we are using, right? Perhaps the most important thing here is just the writing style that we've adopted, right? Information mapping principles. And then the project scope is nothing more than just a brief description of the software that you are building, focusing on why you're building that software, what specific problem it's going to help address, right? And you notice that immediately, I'm hoping that people are thinking about the certain aspects of the proposal, right? In the proposal, there was that section that was tagged as being the problem statement. So what you wrote there could easily be rewritten and then placed in the project scope itself. Now granted, there's room for you to include a reference to that particular document, right? So there's section 1.4, which points to reference documentation associated with this SRS. So it's a reference to additional documentation that whoever is reading this document would have to refer to for them to better understand some aspects of the document. In the SRS document associated with the case example, you will notice that we are making reference to the coding standard that we are using, that we've adopted for that particular project we're working on, but also the document that is tagged as the problem statement, right? So whoever is reading this document would have to reference these two documents for them to better understand some of these things that are in here. Easy stuff, right? Writing writing or coming up with a software requirements specification document is not a difficult task if you just learn to follow the rules. And this is the thing about software engineering, right? Software engineering, I mentioned a while back, that is all about tooling here. It's about tooling and following the rules. There is a whole bunch of standards. You will soon see that literally our entire discussion of system design is based on following the rules, standards. You just don't wake up and say, I am going to create a data flow diagram level zero, a data flow level 0 diagram, and then you just come up with a diagram that looks strange. There's a notation that you follow. Each of these things, all of these things that you're seeing here have meaning, right? Rules. The same goes for those use case diagrams, the use case diagrams we are describing. It's all based on rules, right? The same applies to interaction diagrams, like a sequence diagram, use case sequence diagrams, right? It's all rules. So all you have to do for the software requirement specification document is follow the rules. And following the rules is not that hard, because we've given away the solution. We've given you the template. Say, here's the template. But as we noticed from from the proposals, even when you give people a template, right, they'll prefer to do their own thing, which is quite sad, really. But rules. Talking of rules, by the way, out of interest, have we started looking at rules to do with logical design of or designing relational database management systems? Hello? Can you still hear me? Could someone say something? I'm not sure if you can hear me here.
We can hear you, sir.
Yes, sir, we can get you.
Yeah, but this is a very weird class here, right? Maybe we have bad actors in the house or something. I don't want to say anything. Have you started looking at entity relationship modeling?
Yes, sir, we have.
Okay. Yeah, it turns out that one of the artifacts you're supposed to look at here is entity relationship modeling. Maybe we can skip that if you've already seen that. So we get to focus on the more important parts, right? The more important parts here. But yeah, anyway, great stuff. Okay, so your section 2 here is just nothing more than an overview of the product and the environment within which it's going to be used. So the idea of the environment, the overview of the product is obvious here, right? The overview of the system itself you're building. The environment is to do with sort of hardware on which the system is going to be deployed, for instance. Software systems that this piece of software is going to have to interact with, right? So the product perspective subsection describes the product in context and its origin, right? You'll be able to see examples as we walk through the case example, hopefully the next time we meet. The user classes are nothing more than an outline of all the different user roles associated with your system. Now remember, we want to draw a distinction between the user classes and the stakeholders. These are two different things here. The user classes and their corresponding characteristics have to do with entities or stakeholders that are going to be interacting with the system. So typically you'd have maybe an administrator or a data entry clerk or something. These are the user classes we're talking about. So you explain all those different roles with a brief description of the characteristics, right? And the description is as easy as what you're seeing here under here, right? So a specific user class. This is a generic thing here, right? Generic user class called postgraduate student, and a brief description of the characteristic of that particular user class and what that particular user class or user role is going to be doing with the system. Yeah. I don't know if you figured this out. If I'm an administrator, the person developing the system has to know that an administrator has root access. An administrator can do anything on the system. They can add users, delete users, they can override certain things, right? So user classes. Section 2.3 is nothing more than the operating environment. This is where you get to state specific software components that are going to be used in conjunction with this piece of software, the hardware platform. So operating system. So if you're developing a piece of application that is meant to run on a Unix-like operating system, you need to specify this in the operating environment so that people know. If you're developing a piece of software that is meant to be cross-platform, you need to explicitly state here. Why? So that the developers know, because this is all important information. The developer must know. And by the way, this is like, could be loosely tied to this whole notion of a constraint or non-functional requirement, right? The person developing the system needs to know, right, all these different things. If it's a web-based application, is it meant to be used, should it work on Chrome, on Internet Explorer, on Firefox, on Opera Mini or something, or should we just work on Chrome? I don't know if people have come across pieces of software where they'll tell you to say, for optimal use of this piece of software, use Google Chrome or something, operating environment, right? I don't know if people have come across those things. And you want to be explicit because the behavior of the system might be different if it's designed for a, if it's designed for, oh, wow, it's designed for, about Chrome. If it's designed for a particular version of Chrome, maybe the behavior of this piece of software might be different if you run it on a lower version of Chrome, right? And I hope that this is like going back in history here. I hope this is a reminder of some of these pieces of software you've come across where you are told to say this piece of software should be run on Windows or something. I've come across weird pieces of software, like I'll give you an example, right? We use at UNZA, we use this application called Publish or Perish. We use it a lot. And Publish or Perish can only be run on Windows. You cannot, funny enough, you cannot run this on a platform other than Windows, right? So obviously the people that were developing this probably wrote in their SRS document to say this, the operating environment for this would be Windows. The way I'm able to run this on Windows is by taking advantage of is an emulator, right? So I run this using an application called Wine on Linux, right? Wine allows you to run Windows application within a Linux-like operating system. So, but the key thing here is you want to make sure that you explicitly state the operating environment. Yeah. 2.4 is nothing more than design and implementation constraints. Now, this is your opportunity to explicitly state details to do with specific programming languages, technology stacks that you're going to use, specific types of databases. Hopefully, you've got into a stage where you are discussing the different types of databases, NoSQL databases, relational database management systems, graph-based databases, document stores, and all those fancy things. This is where you get to state, right, explicitly to say, this piece of software is going to require a database management system, but it has to be a graph-based database. It has to be a relational database management system. You can be more explicit and just specify we want it to run on MySQL, right? And again, the reason you're doing this is because it's entirely possible that you might subcontract a third party to develop this piece of software for you. They need this information. They need to know the decisions you've made with regards to what sort of programming languages, libraries, frameworks that you're going to use. Yeah, if you're using, if you're developing a mobile application, are you going to use some cross-platform framework like Ionic, for instance, or React Native, or do you want to build an Android-specific application? You're only focused on the Android platform. You sideline the people that have iPhones, for instance, or people that have Windows phones, right? So things to think about. Specific code libraries that you're going to use, important libraries. What you notice in the example that I've given is that for this particular, the case example, by the way, is actually based on a specific piece of software that we've been implementing for quite some time now. It's being rolled out in phases. Some phases haven't really been done as well as we had hoped here, but you notice that in our case, we've explicitly specified the frameworks we want. This is going to be a web-based application. It's going to use the MERN stack, right? Meaning that the database that's going to be used is a NoSQL database, document-based database called MongoDB. We're using a specific type of framework called Express.js or Express.js. We're using a particular type of framework to implement our user interface. It's React.js. We're using a specific runtime environment on the server side. It's called Node.js, right? So it's a main stack. If I give this SRS to someone in India or in China, they'll be able to build what I want because I've taught them exactly how I want the software to be built, down to the dot, right? Including, where is that? Oh, wow, it's not there. Including coding standards. Appears I don't, including specific coding standards, right? And this is important, really. It would be important for somebody like me because, oh, there's a coding standard, the first entry here. This is important for somebody like me because once these people get back to me, right? And they'll get back to me because they need to be paid. They get back to us or get back to me and say, we are done. We've developed this piece of software. We'll be able to verify and cross-check what they've done by making reference to this this source of truth, which we are calling the SRS document. Good stuff. All right, and then finally, 2.5. I'm saying finally here because we'll cut it short at the time. You include any assumptions and dependencies associated with piece of software that you're building here. Is there anything that your system is dependent on here? You also include any assumptions associated with the business rules. Now we probably, in an ideal case, I mean, if you're reading up online, I'm sure you'll probably come up with, you've come across so-called vision and scope document. It's not uncommon for you to develop a separate vision and scope document and then come up with a SRS document. Some people will take the approach which we're taking right now, where you include anything to do with like business rules, you incorporate them as part of the requirements, right? So any assumptions related to the core business that the piece of software is going to help address should be included in 2.5, including the dependencies. I'm going to pause here and just ask if people have any specific questions to do with this, and then I guess we can call it a night here. Cleaning the head, 8 people so far. Are there any specific questions? All right, no questions. There'll be plenty of questions in the exam. I don't know if you, sorry?
Oh, I have a question.
Yes, before you say that, if you haven't figured this out yet, if you're one of those people who's not reading this, you better read, right? This is not a difficult course, but the problem is there's so much that we are looking at. It's bulky. You better read, you better understand this, because I assure you this is not... Anyway, yes, Master Elijah, question?
Can you just go back to the presentation slide?
Okay. Where exactly?
On the part where you are specifying, saying like the types of databases that will have to be used in the programming languages.
For the design and implementation constraints?
Yes.
Yes.
You said that we're supposed to state exactly the types of databases in the programming languages that we'll have to use. But
Yes.
what happens if we forget to add a what happens if we forget to add a specific type of programming language? Then if we find out maybe, let's say, a few days later after submitting the work, can we go back and edit the work, or
Yes.
one is supposed to be answered?
Excellent question. Immediately after the table of contents, you have this thing here. You see this?
Yes.
Yeah, this is why it's there. It's a continuous process, right? And you see once we look at requirements change, right? Great question, by the way. Somebody's paying attention here. You see this once we look at requirements change and how we get to manage these changes. This is it's not like it's set in stone here. This document is going to change, it will evolve. And you'll see exactly when it's going to change, because the first time we produce this document, it will have gaps, right? We will revisit it once we discuss certain design artifacts as part of system design, those unified modeling language anyway. So as we are modifying this document, we specify when the change was made and why the change was made. And the specific version of software and the specific version or release associated with the release of the software associated with that change. Software is a version, right? Download Chrome version 2 or whatever, these versions, you see this? These versions signal the fact that the requirements changed. The changes that were made to this piece of software based on input from God knows where, right? For Chrome, I mean, right? Does that help answer your question?
Yes,
Yeah,
it has. Thank you.
It's not like when you're told to do something, it's not like, but of course, I mean, come on, if you forget an obvious thing that's supposed to be in release number 1, then there's a problem there, right? You know, like it would be sad if you forgot to include the purpose of the document. That doesn't make sense, because the initial version of this document is supposed to include these important details. It's trivial stuff, right? Yeah. Any other questions? See, when you see me, I see there's 4 people in the house. This is sad, right? I'm wondering how people are going to write anyway, maybe they will. The exam and the test here. Wow. This is, I think this course is going to have a lot of repeat cases next year. Thanks a lot, guys. I'll see you when you see me, which is, I don't know when. Bye-bye. Thank you.
On Thursday.